Hi, welcome back. Today's video is on the Pythagorean Theorem. Our essential question, what is the relationship among legs and the hypotenuse in a right triangle? So grab a pencil, here we go. We have three vocabulary words that we need to get down before we get started. Right triangle should be the easiest one. A three-sided polygon, we're looking for that box. Okay, now I'm moving things. The box in the corner to denote the right triangle or the right angle. So the 90 degrees formed by two perpendicular lines give us a right triangle. The legs, write down, is the sides that form the right triangle. So you have leg here, and then the hypotenuse is always diagonal from the 90 degrees. So it's the side opposite the angle. It's the longest side of the right triangle if you want to add that to your definition as well. Get it down, press pause if you need to, and then we're going to get going. So once upon a time in Greece, there lived a man named Pythagoras who was a mathematician. He had all these followers, students, whatever, who helped him prove this theorem. It's called the Pythagorean Theorem. In a right triangle, the square of the length of the hypotenuse is the lengths of the legs. So if this is, let's scroll down here, if this is 3, length is 3, and you square it, and you got 9, and this is length of 4, and you square that, and you got 16, and the hypotenuse was a measure of 5, he said that 9 plus 16, the two legs added up, would equal 25, and the square root of 25 would be 5. So we're dealing with squared and undoing equations with square roots today. So a squared, or leg squared plus leg squared, is equal to hypotenuse squared. Here we go. Example 1 on the bottom of your notes. Find the length C in the triangle below. So our theorem is a squared plus b squared is equal to c squared. And we are plugging in 6 squared for a plus 8 squared for b. Does it matter if a and b are reversed? Absolutely not. Is equal to c squared, or the hypotenuse. So 6 squared is 36, plus 8 squared, which is 64, is equal to c squared. So if we add up 36 plus 64, yes, you'd get a calculator for this lesson, so you'll be so excited. 100 is equal to c squared. To undo an equation that has a squared in it, we have to use the square root. So using the radical symbol on your calculator, not that you needed to, but the square root of 100 is equal to c, so c is equal to 10. At this point, we need to check our picture, make sure that there isn't a label, meters, centimeters, yards, whatever the heck they were talking about in the problem. In this case, there's not. We don't need to label our answer, and we are moving on. Find the missing length in the triangles below. Before we get started on this back here, this is a repeat of the front, so we are going to change this second problem to different lengths, so we are not repeating ourselves. So if you could alter that figure, and we will get going. Example 2, we've got legs of 5 squared plus another leg of 12 squared, and we are finding the missing length of c or x or whatever you want to call it. And then we're doing the math. 5 squared is 25, 12 squared is 144, is equal to c squared. We add up the sum, which is 169, is equal to c squared. Undo the squared with the square root. Square root of 169 is equal to c, so c is equal to 13. In this case, we do have a label that we have to make sure we put in our final answer. So c is equal to 13 centimeters. All right, in example 3, they give us a hypotenuse, and we are solving for x. So x squared plus 15 squared is going to be equal to 17 squared. If this confuses you, please remember the hypotenuse is always diagonal from the right angle. And then plug in the numbers into your equation. So x squared plus 15 squared, which is what, 225? Yep, 225 is equal to 17 squared, which is 289. To undo addition in an equation, we subtract, so x squared is equal to 289 minus 225. So x squared is equal to 64, and the square root of 64 is 8. So x is equal to 8 centimeters, for example, 3. So far, so good. If the sides of a triangle have lengths a, b, and c units so that a squared plus b squared equals c squared, then the triangle is a right triangle. So for the rest of the video, we are discussing on proving whether Pythagorean theorem is working for the 3 lengths given in the problem. So they start us off with 36, 48, and 60. We are to assume the first is A, then B, and then C and C if they add up, and Pythagorean theorem is true. If you want to simplify those numbers and divide by 12, go for it. If not, use your calculator. 36 squared plus 48 squared is equal to 60 squared. So 36 squared is 1,296. Trust me, I did the work ahead of time. Plus 48 squared is 2,304. Is equal to 3,600. So if we were to add these up, like I said, you're going to get a calculator anyhow. 3,600 is equal to 3,600. So yes, it is a true triangle because the 36 squared plus 48 squared did indeed equal the 60 squared. All right, we got 3 more to do. Do the sides 9, 12, and 15 form a triangle? The better you get at this theorem, the more that you can recognize 3, 4, 5 are multiples 9, 12, and 15. So yes, indeed, it should work, but we're going to go ahead and prove that. Anyhow, 9 squared is 81, plus 12 squared is 144, is equal to 15 squared, which is 225. So 225 is equal to 225. We answer yes for problem 2. Problem 3 is 6 squared plus 7 squared. Does that equal 8 squared? Well, we know a 3, 4, 5 works. Let's see if a 6, 7, 8 works. So 36 plus 49 is equal to 64. That does not look like it works. 85 does not equal 64, so no. 6, 7, 8 is not a right triangle. Whoop. All right, 6, 8, and 10 are left to finish the video for yourself. We'll discuss that in class tomorrow. Have a great night.